Hello and welcome back. In this video, we'll go over how to build a portfolio optimization spreadsheet from scratch. So we'll just take historical return data, and that'll feed all the matrices that we need to do the optimization exercises we've been doing, right? Find an efficient portfolio on the efficient frontier. So let's get into it. We'll look under in-class exercises. We'll work off of a spreadsheet, March 24th, portfolio models. Let's open that up. And a lot going on in this spreadsheet, but essentially what's going on the left is we've got historical data, 40 years of historical return data for three asset classes. Large cap stocks, right? S&P 500 total return, including dividends, and then 10-year treasury bond total return over the last 40 years, and also the return on corporate bonds. So given this historical return data, we can answer questions such as like, okay, if I have some risk objective, what's the best portfolio for me, right? What's the optimal combination of weights? Well, it's one on the efficient frontier. It's the one that maximizes expected return. So let's go over how to build that. And this will be a good skill to have as you look forward to being evaluated on it on the next exam, which is Tuesday, March 31st. So in this video, we'll focus on building the R matrix and the variance covariance matrix. And then the next video, we'll do the optimization, right? So the R matrix, here's a 3x1 matrix of where we could put the average returns, right? R is a matrix of average returns, the historical average returns for the three assets. So let's find that together. So average of the S&P 500 over the last 40 years, 12.99%. Probably going to be a bit below average return year for the S&P if I had to guess, but we'll see. It's early. And then the average return for 10-year treasury bonds, average return for 10-year corporate bonds, triple B rated bonds. There we go. We've got an R matrix. So now the next thing we need is the variance covariance matrix, which I've got here. Right? We'll put it here, a 3x3 area because there's three assets. So the output will be a 3x3 matrix. And there's a little extra space around for the labels. And so the variance covariance matrix shows how volatile each of these three asset classes are and how the returns either move together or move in different ways. So the easiest way I know of to build the variance covariance matrix in Excel is using data analysis. So let's click on the data tab. Data analysis tool pack is right by solver. You don't have data analysis on your Excel enabled device, Google search, enable data analysis in whatever operating system you have. And so let's check it out. Data analysis. The thing we want is covariance, right? So click on covariance. And so the input range we'll give Excel is the historical return data for the three columns of asset class returns. And I'll include the first row, because then that'll allow us to, it'll use the first row as labels. Right? So you select the data on the input range and check the box labels in the first row to denote that this first row is not data, it's labels. And then where do we want Excel to put the covariance matrix when it's done? Let's just put it in a new worksheet apply. I suppose we could name the work. Let's just click OK. And here it is. Let me widen the columns. So this shows the variance of the S&P 500, variance of 10-year treasuries, variance of the corporate bond, triple B rated bond returns, and their covariances, right? You'll notice Excel left out these entries in the matrix, the covariance matrix, right? Because it's a symmetric matrix, meaning like this value here would be the same as this value, right? These would both correspond to the covariance between the S&P 500 return and the treasury return, right? 10-year treasury return. So Excel leaves that out because it doesn't think we need it. We do actually need it, but so here's the variance covariance matrix, or most of it. Let's a couple steps on transforming that into something that's actually 3x3 that we can use for our matrix operations. So let's check that out here. So to do that, let's copy this variance covariance matrix, and then we'll paste it right here, right? So I'll highlight, I've got a little space for it. And what I'll do actually, why don't we start by pasting values on the Home tab, paste, let's paste special. just to illustrate. All sorts of paste options, just paste values. Okay, so that's paste that stuff. And then there's an easy way to get these other entries in here. Right? We could make cell references, have this cell equal to that cell, but if you just keep this range highlighted, an easy way to get these empty cells filled is if we go back to paste special again, let's paste values again, and then two other options. Transpose, meaning it'll take each row and paste it as a column and vice versa, right? Like transposing a matrix. And then also skip blanks so that Excel won't take the blank cells from the source that we're copying from and paste blanks over existing data. So if we put skip blanks and transpose, then Excel will just fill in only missing cells. And here we've got a symmetric variance covariance matrix. So in the next video, why don't we plan on using this R matrix and then this variance covariance matrix and then a weight matrix to do some optimization. All right. See you next time. Thanks.